My name is Daniel Andrade and I'm super excited to teach you about this open source board that everybody has been talking about in the past year called Arduino. Arduino is an open source platform microcontroller that you can use to create electronic projects, automate things, and does input, outputs, interrupts, and much more. We will start this course from the beginning, giving you an overview of the platform by doing small projects, which will then combine into the final project, which will be to create a Moodlamp based on the temperature of the room. For example, if the room is cold, our Moodlamp is gonna be like bluish, and if it's hot, it's gonna be reddish. I'm gonna use the same thing, similar to the one you can see on my side here. This course is intended for beginners, people who have never used Arduino before or have never played with electronics. But if you're a veteran, have worked with different microcontrollers, and want just a quick way to start using Arduino, I want to invite you also for this course. So let's get started. To follow this course, you will need an Arduino board, which I'm holding right now. This is one Arduino Uno. I'm going to talk more about this later. You're going to need also a USB cable to connect the Arduino to the computer, and also that's where we're going to power the board. You will also need a breadboard in which we're going to use to prototype our projects. You will also need for this course a DHT11 temperature and humidity sensor, some resistors, and some LEDs. We also need a RGB LED for our project. Anyway, all the components and parts in Arduino, I'm going to be giving you guys a link where you can buy it or look for it. So, what is an Arduino? Arduino is this open source hardware prototyping platform that was created to help anyone to get started with electronics and start building right away without needing to have very deep background on electronics and programming. First thing we need to go is to arduino.cc. That's where we can download the Arduino software. You can click here in download, and then you can choose for which operational system you want to download. They have like for Windows, Mac, and Linux. In my case, as I'm in the Mac, I'm just gonna click in Mac and download. Okay, now that we have the Arduino software installed, let's open and create our first program. This is the Arduino software that we just installed, and the first thing we have to make sure it's that go to Tools, Boards, and select the one that corresponds to the Arduino that you're using. For example, we're using the Arduino Uno, so I'm going to select Arduino Uno. One good thing to do whenever you start a program is to comment your code, where you can add any kind of information that you want about the code. It's not going to be sent to the Arduino in the end, it's just for your understanding. What you can do is either / to comment a line, or / to comment multiple lines. For example, this is my first program, which is awesome, and I can tell my name here. Okay, so the first thing I'm going to do is define one integer called LED pin 13 semicolon. What does this mean is that it's an integer is a variable named LED pin with the value 13, and there are two things that are important to have in the code. It's setup and a loop. In this case, for example, you have to always start with setup in brackets, so whatever you want to do inside the brackets is going to be run once the Arduino is connected to the power. And that's in here is where we define which pins on the board are we going to use. In this case, it's called there's a function called pin mode, which we're going to use to set up as an output. Usually we use outputs whenever we want to turn something on and off, and let's say an input when we're going to use a button. In our case, we just want to turn the LED on and off. We're going to use the pin mode 13, which is our variable LED pin, as an output. And then the second thing that's important to have is the loop. which it works like this. The loop function is where our program actually is gonna run, and whenever you program a microcontroller, it always works in a loop. It's going to run this function loop until you turn off the microcontroller. Now we want to make the LED turn on for 1 second, turn off for another second, and then keep doing that, making it blink. We're going to use a function called digital write, which is going to turn the pin 13 high, which means it's going to output 5 volts on the pin. We're going to use a delay for 1000 milliseconds, which actually 1 second, and then another digital write low, turning off the LED. Sorry, I was like delay. Okay, so what this program does now is we have integer variable LED pin, which is pin 13. Once we plug the Arduino, you're gonna set up the LED pin as an output, and then we're gonna go to the loop, digital write, turn the LED on, wait a second, turn it off, wait another second, and then start over. So let's see what's gonna happen. So first thing we have to do is to connect our Arduino to the USB cable, and it's gonna turn on. Let's go back to our code. Now all we need to do is press the upload button, and the code is gonna go to the board. And as you can see, it's working. Good job. Awesome. Now that you completed the first task, I want to propose 2 challenges. The first one, I want you to get the code that we just made and change it so that the LED is going to blink faster. Great job. Okay, now that you have the LEDs blinking faster, I want to propose a challenge that's going to be harder than the one before, but I believe you can do it. So, do you know Morse code? I want you to change the code that we just made, and I want the LEDs to blink doing the SOS. So, we're gonna blink the LEDs 9 times. 3 times fast, 3 times slow, 3 times fast. And then we have a bigger break. Let's see if you can do it. So here you have the example that I want you to make. It's a SOS generator with the LEDs, so they blink 3 times fast, 3 times slow, and then 3 times fast. You can do it. So the next topic that we're gonna cover in our course is serial communication. That's when we want the Arduino to send information to the computer, or the computer to send information to the Arduino. This is very useful if we want, for example, to use a sensor, and we want that the sensor sends information to the computer, and then from that data we can, for example, plot a chart or turn something on the computer. After we cover the serial communication, it's time to get started with our temperature sensor. That's going to be a lot of fun. Let's go. To have some understanding of the serial communication with Arduino, I'm going to create this simple program where we're going to tell Arduino to send some information to the computer. So the first thing that we have to do in the setup is tell Arduino that we're going to use some serial. All we need to do is write serial.begin. And what this function does is it initiates the serial communication, and the 9600 is the communication speed, but you don't really need to understand very deeply how it works. The first thing, let's tell Arduino to say hello. Now let's tell Arduino to say hello every time it's connected. So we do a serial print line, and then we can write a text here. Let's say hello world, and we cannot forget our semicolon in the end, and you can also not forget to put a delay, otherwise it's going to be too fast. That's what's going to happen. Let's program the board. Press upload. Let's select the board. Okay, uploading. Now it finished upload. I can go to serial monitor. That's where we can see what kind of information Arduino sent to the computer. As you can see here, it's sending hello world with a delay of 1 second. Let's do something more fun. As we did in our previous code, we set an integer, but this time I'm gonna call it x, and I'm gonna say that x is the same as 0. Let's do some math here. So every time the loop goes through, I want the x to be increased by 1. So I'm gonna do a serial print line in the value of x. This time, if I program the board, it's going to show only as 0, 0, 0, 0. Okay. But I don't want it to be 0, I want it to be increased every time. So what we can do is do a x, it's gonna be the value of x plus 1. And then our famous delay. What this function does is that every time the loop goes, it's going to increase the value of x. So the first time x is going to be 0, so 0 plus 1 is 1. Second time x is 1, so 1 plus 1 is 2. And then it's going to loop forever. So let's upload our code and see what's going to happen. Let's go to serial monitor. And as you can see here, every time it loops, it increases x by 1. Really cool, right? So before we get started with our temperature sensor, I'm going to talk a little bit about the breadboard. So here we have a red breadboard, and the way that it works is that all the connections, all these little holes here in this line, they are all connected in the same spot. So for example, if I have this LED here that I have in my hand, if I put them the way that they are here, it means that the two pins from the LED, they're connected together, therefore it's not gonna work. So everything that you're gonna use a breadboard, you always have to connect them sideways like this. In the sense, we're gonna use our DHT11 sensor. This is our temperature and humidity sensor, and it has 4 pins. So in order to connect them to the breadboard, you don't connect them this way, because this way you are short-circuiting all the pins. The proper way to do it is select them like this. Okay. As you can see, it fits perfectly. So looking in front of the sensor, we're gonna have pin 1, 2, 3, and 4, where pin 1 is gonna be the power, the VCC. The pin 2 is the one that we send the information, so it's the data pin. The third one we're not gonna use, and the fourth is the one that's gonna be connected to the ground. So let's take a look on how we actually connect them to the breadboard. Okay, so let's start connecting the temperature sensor to our Arduino. So the first thing that we're going to do is connect the pin 1 like the picture before. It goes from this pin to where it says 5 volts on the Arduino board. Next step, let's connect the ground, which are the opposite pin, which is pin 4, and we're going to connect where it says GND or ground on the Arduino board. And our last pin that we need to connect is the second one, where I'm going to use this yellow cable here, and I'm going to connect to the digital number 4. Okay, just one thing that we need to remember is that we need to connect a resistor between the first and the second pin. So I'm just gonna get my resistor here, and I'm going to connect between pin 1 and 2. Okay, let's go. Perfect. After we have all this connected, it's time to test the code. Before we start programming our temperature sensor with the Arduino, what we have to do is to download the library that's gonna make much easier to program our sensor. So first thing that we have to do is go to download the library from Adafruit. Don't worry, all the links will be provided for you. So you go here, download zip file, and I'm going to put in the download folder. We are going to unzip this file, and you see that it's called DHT, so we have to rename this folder for only DHT, the same way as the files inside. Okay, we're gonna copy this folder. Let's go to Applications, Arduino, Show Package Content, Contents, Resources, Java, Libraries, and we're gonna paste the folder into this folder. So the library is installed. Now let's open our Arduino application. Okay, awesome. Once having the library installed in our computer, let's create a simple program and see if the temperature sensor is working. So the first thing that we have to do is include the library that we just downloaded. So it's called dht.h. That's gonna load all the functions that that library provides. We configure our temperature sensor to work with the pin 4. So let's use a function called define. Let's call it DHT pin, and let's say that's 4. One other thing that this library requires, it's to say which kind of temperature sensor we are using, as there are DHT11, DHT22, and DHT21. In our case, we are using the DHT11. So we're gonna define, let's call it DHT ID, and let's say that DHT11. We can just add some comments so we can remember what we're doing. Defining the sensor type, and then defining the sensor pin. Okay, awesome. The library requires one function that is gonna be DHT pin, DHT type. So what it does is that it tells that we're going to use the DHT function, and it's connected to the pin 4, and the type that we're using is the DHT11. So like we did before in our serial communication class, let's start the serial communication at a baud rate of 9600. Let's start serial communication. Awesome. To initialize the sensor, we have to do a dht.begin. Okay, seems that everything is ready. Now let's go to our loop. What we're gonna do here is create a variable that's gonna hold the value for the temperature in Celsius, the temperature in Fahrenheit, and the humidity of the room. So I'm going to start with a float variable called age. What's different with a float and int? Int means integer, which is a number that's gonna be either 1, 2, 3, 4, 5. A float can be a number that's like 1.2, 1.3, not a whole number. Because the sensor has an accuracy more than full numbers, we're gonna use a float variable. And age is gonna be for humidity. So what we're gonna do is like dht.read humidity. Whenever we use this function, you're gonna put in the variable age the value for the humidity. Let's say read humidity. Let's read the temperature in Celsius. I'll call it TC. It's gonna be the same thing as before, but this time we're gonna call it dht.read temperature, and let's call it read in Celsius. Okay. Float, I'm gonna call it temperature Fahrenheit as dht.read temperature, and true. True means that it's gonna give the information in Fahrenheit. Let's comment read temperature in Fahrenheit. Awesome. So what our code is doing right now is reading the information from the sensor. Now we have to display this information somehow so we can understand what's happening. And for that, we're going to use our famous serial communication. So let's first start sending the humidity readings. So serial.print, let's call it humidity, and then you see here I didn't put a ln. Whenever I use print ln, it means it's going to print the information and it's going to jump for the next line, and that's not something I want because I want to display a whole string of information. If below this I write another serial print, it's going to be displayed in the same line, so I'm going to call this age. So what is going on here now is going to show in the same line humidity, space, and the value that we are reading from the sensor. Because the sensor gives us a temperature reading in percentage, I'm gonna make another serial print, and this time I'm gonna show a percentage. Okay, before we go ahead, let's just see if it's working. I think that's a good thing to do. Oh, there's something wrong in our code. Let's figure it out. Oh, because the problem is that I call it DHT-ID. Okay, I made a mistake here. Okay, should go now. Okay, it's uploaded. Let's see if it works. Oh no, something's wrong. Ah, I know why. You see that the information is going very fast and everything in the same line. It's because we didn't put a delay and because we didn't ask to print the information in a new line. So let's fix it. After everything, let's do a delay of 2 seconds. That's more or less the time that the sensor takes to get a new reading of the temperature. And here in the last line, I'm gonna do a print line, which is gonna give you a new line every time. So let's program and see what happens now. Oh, perfect, much better. So every 2 seconds, and it's reading and it's giving the humidity of the room. We have here 19%. I guess it's pretty dry. So let's go ahead and finish our code. So I don't want actually to print another line just yet. I want to continue to print the information from the temperature now. I want to finish the information from the humidity with a percentage. So percentage, and then let's show the temperature. Same thing as we did before. It's gonna show temperature in Celsius. Awesome. And serial print to say it's in Celsius. And now let's display the temperature in Fahrenheit. Let's code here. And print TF, just like we did before. Serial.print Fahrenheit. Because this is the last one that we're printing, I want to do a print line so it breaks into a new line every time. So let's see what's going to happen once you program this. So let's see. Humidity 19%, temperature 21 Celsius or 69.8 Fahrenheit. Perfect, right? There you go. We have our temperature sensor working. It's time to go for our next class. Awesome. So I hope you guys are having fun. It's the last part of our course, and now we're going to learn how to use these really cool RGB LEDs that you can control the color. And after we learn how to use this, we're going to finish our project combining everything that we learned into creating our Moodlamp that changes the color with the temperature. Let's go. So taking a close look on the LED, we can see that it's pretty easy to understand. Here you have in the both sides a plus sign, which means we're going to connect them to the 5 volts coming out from the Arduino. The G pin in both sides mean ground, so we're just going to connect them to the ground on Arduino. And you see there's an I and an O, which means there's an input and output. This way, for example, if we only want to connect one LED, we're going to connect this pin I going to the port number 6 on the Arduino. And in case we want to connect, let's say, 2 of these LEDs, we can just connect them together, connecting all of them in the 5 volts in the ground. But the thing that we have to change is that the output from one goes to the input to the next one. So let's connect them to the Arduino and try to understand how to program them. Okay, same way as we connected the temperature sensor before. Okay, first thing that I'm gonna do here is connect the plus sign that goes from the LED, and I'm going to connect to the 5 volts in the Arduino board. Perfect. I'm gonna get a black cable. I'm going to connect on the G, which means ground, like that, and I'm going to plug into the ground from the Arduino board. And for last, I'm going to get the input from the LED, and I'm going to connect to digital pin number 6. Perfect. Now we are ready to program our LED and have fun. Perfect. Before we start programming with the LED, we have to download the library. Same thing that we did on the DHT sensor. So we're going to the library website from Adafruit. All you need to do, the same way as we did before, click download zip, save it. It's going to download in our download folder. So the name of the file here is Adafruit NeoPixel, the same one as the folder. Okay, I'm going to copy this folder, go to applications, go the same way to the Arduino, show package content, and then go all the way to the library, and then we're going to paste it. Okay, it's here, Adafruit NeoPixel. Perfect. And now we are ready to start coding. Let's start programming our LEDs. The first thing that we have to do is to import the library that we just installed in our Arduino. Okay, so we can go to Sketch, Import Library, and you see here the first one, it's Adafruit NeoPixel. Let's click, and now we have here our Adafruit library inserted in our code. Let's start programming our LED. So there's one function that's important to add whenever we're going to use these LEDs from Adafruit. It's called Adafruit NeoPixels, and then the variable pixels, it's going to be here. The number of pixels that we are using, in our case 1, and the pin that we connect our LED, in this case 6. Actually, to make our code look a bit better, I'm going to define LED pin as being 6, and I'm going to define numbers as being 1. So this way, in case we want to change the pin or the number of LEDs, all we need to do is change in these variables here. Okay, so here is numbers and then LED pin. Okay, so the setup here is very simple. As we call the function pixels, we're gonna have here pixels.begin, which is going to start our RGB LED. And then we go to our loop function, where we're going to define what's going to happen with the LEDs. So the function works like this. We're going to call it pixels, which we defined before. Now we're going to set the color that we want the LED to be. So it's called set pixel color, and then which one of the LEDs we want to do. In our case, because we only have one LED, we're going to call it 0. We have to understand that whenever we are counting, we always start from 0. So instead of starting from 1, 2, 3, we're going to start from 0, 1, 2. And in this example, we only have one LED. So the first one is called 0. Then we're going to define the color that we want. Pixels dot color. We have a RGB color, which means R means red, G means green and B means blue. So we can combine any of these three colors to make another color. In this LED, we have RGB, and to make different colors, we can combine them by changing the brightness of each one individually. Instead of going from 0 to 100%, the numbers that we're going to use, it's from 0 as being completely off to 255 being completely on. For example, if we want the LED to be red, we're going to set 255 in the red color, 0 in the green color, and 0 in the blue color. Let's close everything, and after we finish setting the color that we want to do, we have to send this information to the LED. Pixels.show. This way, our color is going to be sent to the LED. So let's start with a simple program. I want the LED to blink red, green, blue, and then looping this all over again. So let's do one delay for 1 second this time. Let me just copy the same function here 3 times. So we have here, the first time is 255. The second time I want it to be green, so I'm going to call it 0 for red, 255 for green, 0 for blue. And then in the last case, I want it to be 0 for red, 0 for green, and 255 for blue. Let's see what happens when I burn this code in our microcontroller. Let's connect the board, and voila, we have our circuit working and the colors are changing. Before we can continue with our project, there's something I want to teach you that's going to be very useful in your next Arduino project. It's called for loop. Let's say that this time, instead of just changing the colors from red, green, and blue, I want them to go from 0 until 255 on red, 0 to 255 on green, and the same thing on blue. So it's gonna make a very nice effect on the LED. But imagine if you have to do this like every time, one by one, for example, and then it starts in 0, and then 1, and then 2, and then 3, and so on. This way, the color red is going from 0, which means turned off, until 255 with full power. But that's gonna be a lot of work. So in order to do that, we're gonna use something called for loop, which will increase the brightness of the LED without you having to rewrite this function many times. So every time you're going to use a for loop, it works this way. You start typing for. We're going to call a variable that's going to be our loop variable. We're going to say it's an integer called I, and we're going to start this as being 0. Semicolon, and then we want the I to go from 0 until 255. So I starts as being 0. We're going to have this function going as long as I is less or equal to 255. And every loop we want to increase the value of I by 1. So I, it's going to be I plus 1. And we're going to add some brackets. So everything that's going to be inside this for loop, it's going to happen 256 times, because it starts in 0 and then go all the way to 255 one by one. So what we can do here is just copy this code, and instead of having the red color starting at 0, we're gonna switch this for the variable I. So the first time this loop goes, we're gonna start with the color red being 0, and then it's gonna go again, and the color is gonna be 1, 2, 3, and so on until it reaches 255. For you to understand, I'm just going to remove the other colors, and I'm going to add a delay here of 100 milliseconds, and I'm going to upload this code, and let's see what's gonna happen. As you can see here, the brightness of the LED is changing slowly. Really cool, right? And all this thanks to the for loop. You saw that the brightness only went up and then straight to 0. I want it to go up slowly and then go down slowly. And we're gonna add the same thing for all the colors. Let's just copy this function that we did before, but instead of having I starting as 0, I want I to start at the most bright value, which is 255. but I want this for loop to work every time until I is the same as 0. So as long as I is bigger than 0, I'm going to make I be the same as I minus 1. So this way we're going to decrease the value. And just by changing this, we're going to have the brightness going up and down. So let's add some comments. I'm going to do the same thing for the green and for the blue. Green color, and I'm just going to change the position of the eye, and the same thing with the blue. Let's change here. All this code is available for you right now, so let's upload this and see what happens. Now we have an improved code. The red light goes slowly up and down, then green up and down, and then blue up and down. Really neat, right? Great job so far. Now we're ready to finish our project. Now that we know how to work with the LEDs, we know how to work with the temperature sensor, and we know how to program all of them. It's time to join everything together to create our final project, which will be our really cool Moodlamp. All we need to do is to combine the temperature sensor project with the LED that we did before. So let's take a look how we're going to connect them. So here's the list of components that we're going to need in our final project, which is a breadboard, the DHT11 temperature sensor, our RGB LED, one resistor, our famous Arduino, and some jumper cables. With only this, we'll be able to create our awesome project. Let's get started. The same way as we did before. Let's start connecting our temperature sensor here. The first pin is the 5. I'm going to connect in the 5 volts. Connect to 5 volts in the Arduino board. The last one I'm going to connect in ground. So you can see that above the pin 13 you also have another ground, so you can just use the same connection here. The second pin, with the yellow cable, I'm going to connect on port number 4. Perfect. This way we have our temperature sensor connected. Now it's time for the LED. I'm just going to connect to the board here. Because the Arduino only have one 5 volts on this side, I'm going to just plug in the same position as the 5 volts on the temperature sensor. So I'm just connect here. And I'm going to put this cable on the plus from the LED. We can't forget to add our resistor between the first and the second pin on the temperature sensor. So let's do it now. Let's connect our LED to the ground, which I can do the same thing as I did with the temperature sensor, letting them all be in the same position. And for last, let's connect the in pin from the LED to pin number 6 on the Arduino. Okay, seems that we are ready to roll. Great, so let's start with our last program that is going to combine everything that we learned so far, and that's going to be our final project. Remember, let's just start by commenting the code. Final project Moodlamp that changes color with temperature. Awesome. Let's start with the null pixel variables. So I'm going to just comment here null pixel variables. Add import our library. Then let's define our LED pin as being 6. Define number of LEDs as being 1, and the function that's going to configure our LED. So in this case, I'm gonna change the pin that we're connected to LED to LED pin, and then number of LEDs, we're gonna change the variable here. That's all we need for the null pixel. Now let's configure our DHT11 temperature sensor. We have to import the sensor library. We're gonna define the DHT pin as being 4 because we connected the temperature sensor to the pin 4. We have to define the DHT type as being DHT11, and then just the same function as we did before to initialize. So let me just clean the code a little bit. So the first part loads the information for the LED, and the second part for our temperature sensor. Okay, let's start by typing our setup and loop code, and now we're going to add the information for the setup. The first thing that I want to do is start a serial communication. As we did before, serial.begin. And 9600 is the transfer speed. Do a dht.begin to start our temperature sensor, and pixels.begin to start our temperature sensor. Oops, begin. Awesome. Let me just add some comments to make our code look better. Awesome. So it seems that our setup is ready to roll. Now let's go think about our loop function. Just copying the code that we used before. An integer called h, which is going to be our humidity, t for temperature, and f for temperature in Fahrenheit. This time I don't need a reading to be very precise, so that's why I'm going to use integer instead of float. This way it's going to be much easier to understand our code. So to understand the way that the Moodlamp is going to work, I want the color to be blue, perfect blue, when the temperature is 32 Fahrenheit, and I want the color to be red when the temperature is approximately 120 Fahrenheit. But all the code is going to work in Celsius. So we want a blue code when it's 0 Celsius and red when it's around 50 degrees Celsius. I'm going to define the colors. I'm going to create two variables. One is red and one is blue. And these variables, they need to go from 0 to 255, which is the brightness of that color in the LED, as 0 being turned off and 255 being totally on. For example, if we are in 0 Celsius, I want blue to be 255 and red to be 0. And the other way, if it's 50 Celsius, I want red to be 255 and blue to be 0. But what if the temperature is 30 Celsius? So 30 Celsius is closer to 50 than it's from 0. I want to add just a little bit of blue, and I want to add more red. This way it's going to be closer to the red than to the blue. The way that I define this integer function called red, that its value is going to be temperature times 5. If the temperature is 50 degrees Celsius times 5, it's going to be 250, which is very close to being 100%. And if the temperature is 0 Celsius, it means that the red is going to be 0. Or if temperature is 1 Celsius, it's only going to be 5 instead of 255. What about the blue color? We want the blue to be the opposite as the red. I'm going to create a variable called blue. And for it to be the opposite of the red, I'm going to add temperature times 5. But to be the opposite, I'm going to add a 255 and subtract the value of the red. So let's see if we can understand this. Let's suppose the temperature is 0 Celsius. That's going to give us a red of 0 times 5, which is going to be 0. Let's see the blue. It's going to be 255 minus 0 times 5, which is going to be 255. This way, our LED is going to be totally blue. Let's go to the second one. Let's say it's 50 Celsius outside. So we're going to have red is going to be 50 times 5, which is going to be 250. And then we're going to have blue. It's going to be 255 minus 50 times 5, which is going to be 5. So pretty much the blue is going to be 0 and the red is going to be maximum. This way our LED is going to be red. So now what is going to happen when you have a temperature of 25 Celsius? Let's see. So red is going to be 25 times 5, which is 125. Let's say our blue now. Blue is going to be 255 minus 25 times 5, which is going to be 230. So pretty much it's going to be the same amount of blue and the same amount of red. Perfect. Okay, let's now continue with our code. Now let's display the color in the LED. Like we did before, we just need to pixels.set pixel color on the pixel 0, which is the first one. Pixels.color, and then remember it starts with RGB, so it's going to be the variable red and then 0. I'm not going to use the green in this case, and blue. Remembering that the red and blue variables are calculated above, and then you just have to send this brightness to the LED. So pixels.show. Perfect. And that's all we need for our code. Just to add some more extra information, let's add some serial communication so we can see the temperature and the values that are being displayed. So let's do some serial communication. Serial.print. I want to display the number of red. And now let's print the value of red. Serial.print and then blue. Serial.print line. This time, because it's the last value that I'm adding, I want to add line. Awesome. So it seems that everything should work. Let's try programming this and see what happens. Just one thing that I forgot to add here is that our temperature sensor takes about 2 seconds to show any information. Takes about 2 seconds to do each reading. So let's finish the code with a delay of 2 seconds. Okay, let's program our board and see what happens. As you can see the color, and we have blue as being 155 and red as being 100, which means that it's around 20 Celsius here. Let's add this information to the code. It's going to be very helpful. But before everything, let's just add here serial.print temperature. It's going to be serial.print, and let's display our temperature in Celsius. Okay, let's program again and see what is going to happen. So I was right. Temperature is 20 degrees Celsius. The red is 100 and the blue is 155. So here we have our final project working. As you can see here, the color is between blue and red, which means that the temperature is around 20 Celsius. As a proof of concept, I'm going to put our project into this mini tiny electric oven to see if the color changes to red. You can see here that as soon as I put in the oven with a higher temperature, our color became red, which means it works. Now I have here the Moodlamp outside, which is below 32 Fahrenheit. Therefore, the temperature is blue. Congratulations for finishing the course. I'm sure that during this hour you have learned a lot. And this is just the start for your studies on electronics and programming. I hope that after this hour you have learned enough to start exploring the magic world of electronics in Arduino and start creating your own awesome projects. I really want to see what you guys are doing. I'm sure that everything that you guys learn during this course is going to be very useful for your next projects. And don't stop now. Keep exploring, keep learning, and keep creating awesome projects that I'm sure you guys can do it. If you have any questions about this course, please just message me. It was a pleasure having you guys here. Have fun and enjoy the world of electronics. Bye!